Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to discuss the application of the derivative, that is a related rates. So, in which we will discuss the application of the differentiation. So, before going to the topic, so we have to know some of the mensuration rule, the formulas. So here the volume of the cube is the volume is a cube. This is the graph of the volume of a cube, and this is a cylinder where the volume is V equal pi r square h, and here the volume of cone V equal 1 over 3 pi r square h. So this is the cone, and here the area of a square is a square, area of a circle by a square, and the area of the right triangle is half into base into height. So what are the keywords? How will you identify this one? Whenever it is given as a rate or increasing, it means that the derivative is given. And by the way, here the default variable will be the d theta. So always it is with respect to theta. We are doing with respect to t, with the time. And this is a very important rule we are using whenever the triangle is formed. So using the Pythagoras theorem, we know that so x square, this is z, can be written as z square is equal x square plus y square. So this is Pythagorean theorem. Now, how will you solve this problem, the application problem, word problem in the related rates? So there are the four methods, four steps you will have to do. So first one is to draw the figure of from the question and assign the variable of the quantities. Next, write the formula or the equation that relates the variable. The next step is differentiate, and we will have the last one is evaluate. So just substitute the values and get the numeric value at the last. Let us start with the simple question first. So this is the first question you have. So first read the question carefully. After that you can just make a figure. So a ladder 5 meter long is resting on the wall. So this is my actually the wall, and this is the ladder. So which is resting on the wall, which is resting on the wall. Okay. Then the bottom of the ladder slide down. So this is the bottom of the ladder. So you will have the bottom of the ladder is slipping, slide away from the wall. So it will go down. It will go down. So this is what it is asking here. At the rate. So this is the at the rate which is given. So first of all, I say this one is the x and this is the y, and this is my 50 feet ladder. So first of all, I write it the given terms. What is the given things which is given here? The first one here, it is given as dx over dt. So this is the rate is given. The rate of the bottom of the ladder. Bottom means what? The variable dx. So therefore it is dx over dt. This is the rate which is given 1 meter per second. So this is what it is given. Dx over dt is equal 1. Okay, done. Then how fast? What is the question mark? How fast the top of the ladder? This is the top of the ladder is decreased. So this one, this position is decreased. So this is what the rate. How fast the top of the ladder sliding down, and it increased the ladder when x equal 3. So when the bottom of the ladder 3 meter away from the ground. So this is the question mark. So this is my question mark when x equal 3. When x equal 3. So let us write it here. This is my dy over dt is question mark when x equal 3, when x equal 3 meters, which is given in the question. So what is it relates? What it relates? So therefore It relates this one is a Pythagoras theorem as per. So we can go x square plus y square equal 50 square. So it is, so this is, so 5 meter, not 50. So it is a 5 meter. Oh, sorry. So it's a 5 meter, not 50. So in the question it is mentioned here, it is 5 meter. So it is 5 square. So what happened now? This is x square plus y square, which is equal 25. Now I have to differentiate this part. So what is the differentiation? 2x dx over dt. So this is an implicit that common variable is t with respect to t. Here 2y dy over dt, and the 25 becomes 0. 25 becomes 0. Now what happened the next one? So the 2 is a common. So if I move this one here, so I will move this part here. So what happened? Because I want to find it this part, the dy over dt. 2y dy over dt equal minus 2x dx over dt. What is the cancel here? 2 with the 2 cancel. So 2 with the 2 cancel. So the remaining things we have here. So this is the y. I don't want the y. So dy over dt is equal minus x over y dx over dt. So here we have the x is good. Now dx over dt is also there, but what about your y? The y is unknown still. So how will you calculate y from this one? So y square, I just substitute the value x equal 3. I just substitute, you will get 3 square 9 here, y square equal 25. So y square is equal 25 minus 9, y square equal 16, y is equal 4. So I got it the y value here. So just substitute the value. So here I got it dy over dx is given by minus 3 over 4 dx over dt is 1. So final answer will be minus 0.75 meter per second. Why it is minus? The minus indicates it is decreasing. It is going down. That's why it is a minus. So the 70% of the question, if you understand and extract the value, the things will be over. Only you have to do the differentiate. So the next problem is a car A is traveling at the west at 80 kilometers per hour towards the west, and car B is traveling north at 100 kilometers. So they will intersect at one point. Two roads are intersect. And what is the rate? Here it is the rate asking the dy over dx, the dt, and this is the car A and B distance is given for the intersection. So before going to this one, we have to know the direction of, this is north and this is my west, and this is your east, and this is the south. Now here it is asking here, this is the intersection part. A car A is traveling towards east, that is the 80 kilometers, and the car B, which is move, this is the car B which is moves towards the north. So this is towards east. This is what it is given, and the starting point of the car will be here and here. So this is the intersection part where you will find it the two roads are intersect. So it is a triangle again. So it is a triangle again. So I will complete the graph. It is a definitely it is a triangle. So you will have this one as triangle. Now how will you solve this one? So what are the things which is given here and what you have to find? So this one is given as the dx over dt. This is, I say here x, and this is my y. And what is this one is given? So given things, I write it since it is a speed traveling. So therefore it is dx over dt, which is given by my 80. And here dy over dt, which is 100, which is 100 kilometers. And this is the given part. And what is the given thing? What you have to find? These things, the intersection part, you have to find that dz over dt. We have to find when x is equal 0.3 and y is equal 0.4. So this is what you have to find. Dz over dt is my question mark when x is 0.3 and y is 0.4. This is a kilometer from the intersection part. Now what you have here? The same Pythagoras theorem we will use. This is x square plus y square equal z square. So if you differentiate, or you can write it in terms of this one, z square is equal x square plus y square, because this we have to find. Now what is the differentiation? So 2z dz over dt, and here it is 2x dx over dt plus 2y dy over dt. Now if you cancel the two common factor, so it get cancelled, these two is get cancelled. So what are the things we have? Just you can write it here. So we have this one, and dx dt, x is also there, y is also there, but still there is one term which is missing, z. So how will you calculate z? Is the same rule. So I will make use of the Pythagoras theorem, z square, and since these two values are known, so I can calculate the z value. How will you calculate? So this is this is 0.5, zero point 0.4 square, this is zero point 0.3, x is 0.3. So x is 0.3 square plus 0.4 square is equal z square. So if you simplify, z is equal 0.5. Z is equal 0.5. I got it. Now, so here I write it dz over dt. So it will be divide 1 over z x dy x over dt plus y dy over dt. Now I just substitute the value. So what is this one? Z you have 0.5, x value is 0.3. And what about the y value? The dx over dt. Since dx over dt is going towards, therefore the distance will be reduced. Therefore it will be minus. I say here minus 80 because it goes reducing speed, reducing the distance. Now here the next one, 0.4, and similarly the dy over dt is also 100 kilometers, which is the minus because it moves towards the intersection, so therefore decreasing, the distance will be reduced. Now if you simplify this one, you will get minus 180 kilometers per hour. So this is the distance rate. So this is the distances. Therefore, we say the car are approaching each other at the rate of 108 to 128 kilometers per hour. So the minus indicates this the intersection part, going towards the intersection because they are traveling the distance. So it is, I write it here, car approaching, cars are approaching each other at rate 128 kilometers per hour. That's it. This is the answer. So if you understand the question, it will be very easy. Okay, so the next one we have here, the value. It is a volume is given. So that's why we are giving some recall of the some mensuration problems. So here the volume, if V is the volume of the cube and X be the edge of the cube, and then they expand at the time t. This is a time t. What is find dt in terms of dx? So this is the volume which is given. This is the cube. But here the side edge is mentioned in the question. You cannot assume any edge, but in the question it is mentioned. You have to assume it this one as a x. So therefore the volume will be, I write it here, volume of cube. Just before, at the beginning of the video, we have discussed V is equal, the volume V is equal x power 3. So what I need, dV over dt. Differentiate this part, dV with respect to t. So this is equal 3 times of x square, the power. Now if you differentiate x, it becomes dx over dt. This is the first question. The first one is done. So you have to find the derivative dV over dt in terms of dx over dt. That's it. What about the next part? The next part is given by here. The length of the edge is increasing at the rate. So this increasing at the rate, that is given by, this is nothing but dx over dt is given. The rate of increasing the edges is given. How fast the volume is increasing? This is asking here what? dV over dt is asking when x is equal 15. When x is equal 15. Just substitute the values. So here given are dx over dt is given, which is 4, and x is equal, which is 15, and you have to find dv over dt. So this is my question mark. Just substitute all the values in the question on the above. So what happened here? So this one you have dv over dt. So this is the same thing. I just substitute here in 1. So 3 times of x. X is what? 15 square. And dx over dt, which is 4. If you multiply, you will get 2700. Since it is a cube, therefore it is volume, it is a cubic unit. Cubic unit per second. Because seconds are given in the unit here in the question. So it is centimeter cube per second. So this is the rate increasing of the value. Now let us take the next question here. So each side of the square is increasing, but here it is not given any side. So you can use any side as a x, whatever it may be. I use the s. I use the s. So see, so I will use this one. This is the square is given, and I will use the s. And what is the given things? The given thing, the rate of increasing, this is ds over dt is given. So ds over dt, which is given by 6. This is what? ds over dt. At what rate the area of a square, this is actually dA over dt is asking what is the question mark, when the area of a square is given, then area is 16. So I write it here, the area is equal 16, and you have to find dA over dt is question mark. So we know that the rule, what is the rule here? The area A is given by s square. So s square, differentiate dA over dt equal to s ds over dt. So I have this value. Good. I have to find this one, but there is a still missing the side. How will you find the side? From this rule. There is one more information which is given, thus area. What is the area? S square is equal 16. Take a square root, you will get 4. So I got it, the S, the side. Just substitute 2 times of 4, and this is given in the question, which is 6. So this is equal 48. Since this is a square, this is the area, so I write it here, centimeter square per second. So how will you identify the question? See here. So it is centimeter, it is per second, so it is area square. That's why square. So these are the things you can find it easily from the question itself. Now the next one is a cylindrical tank with the radius. The cylindrical tank with the radius. This is a cylindrical tank you will have. So cylindrical tank So I know the area of this, the volume. So let us take what are the things which is given. This is R is given. R is 5. Must both. So therefore is being with the water, filled with the water, and at the rate, what is the rate it is given? It is given d volume. This is the volume. How will you identify this volume? Because it's a cubic unit, not the d or over dt, because it's a cubic. So therefore it is dv over dt. Volume will be cubed, three dimension. Now my interest is to find how fast the height of the water is increased. Height, this is my question mark. This is my question. Now what are the given things? Let us check here. So solution. So given. So R is given by 5, dv over dt, which is 3, and you have to find dh over dt is the question mark. As I know, so as I know, what is the volume of the cylinder? Volume of a cylinder is given by V equal, so pi r square h, pi r square h. So I just substitute the value first. The r is given, I just substitute before differentiating. This is 25h. So if you write it this one, this is actually 25 pi h. Now differentiate dv over dt equal, this going to be a constant like a c, because all the terms will be a constant. Therefore it is 25 pi as a constant. When you differentiate h, it becomes dh over dt. What are the values you will have? This value you have, just substitute. This is equal 3 equal 25 pi dh over dt. So I need to calculate dh, just bring it this one over. So you will have dh over dt is equal 3 over 25 pi. So if you simplify, you can simplify this one. Since it is a side, the parameter h, therefore it is meter, and see the unit, it is minutes. So I will use the minute here. That's it. So this is how fast the height of the water is increasing. So all the informations you have to gather from the question. All the things you will do it from the question. Last question for this one here. A plane is horizontally flying horizontally at the altitude. What do you mean by altitude? It is nothing but the height. So this is actually the scenario. What is this one? This is a plane. I say here this is a plane which is flying at the height of 2 kilometers. 2 kilometers horizontally at the speed. This is actually the speed is given. This is, I say here, x. We are usually this variable we are assuming x, and this one is the y. This is the y we are taking. And if I complete the graph, so it may be what? So it's again a triangle. So it's a triangle. So therefore you will have this part. Okay. So what are the question is given? Find the rate. This is actually, this one is dx over dt is given. This one is dx over dt. So it is flying with the speed. Speed means rate of change. Acceleration. Yes, 800 kilometers. What are the things you have to find here? So find the rate at the distance of the plane to the radar station. This is going to be a radar station. This is the radar station, and the plane is moving towards the radar station, right? And here we have to find the distance from the plane to the station is increasing when the plane is 3 kilometers away from the station. So I have to find it this dy over dt, dy over dt when the y is equal 3, when y is equal 3. So how will you find this one? So here the first thing, what is the quantities are given of the problem. So I write it the number A given. This is a given part. So here the given values are the dx over dt is given by dx over dt is 800 kilometers per hour is given. So this is the horizontal x be the horizontal speed which is traveling. Now what about the unknown? What is your unknown? It is asking the unknown. What is the unknown? So you have to calculate dy over dt. So at when y is equal 3 kilometers, when y equal 3 kilometers, draw the picture of the situation. This is going to be my c. This is the c. You have to draw the first one and relate the equation of the quantities. What are the relate of this one? This is actually a Pythagoras theorem. As per the Pythagoras theorem, I say y square is equal x square plus 2 square. So this is y square is equal x square plus 4. Is it right? Now what happened now? Then so I differentiate this part. 2y dy over dt, and here 2x dx over dt, and the 4 becomes 0. This 4 become 0. Now with the 2 cancel, common factor. Now if I need this part, so dy over dt is equal x over y dx over dt. Let us check what are the quantities, what are the things we have. Dx over dt, we have it. The y, we have 3. Y, you have 3. But still there is a one unknown. What is that unknown? X. So how will you calculate that an unknown? From the equation, from the same equation. So I will go with the same equation. What is this? So this is y square equal x square plus 4. Y square is 3, 9, x square plus 4. If you move it here, x square equal 5, x is equal root 5. So when I substitute these values here, what happened? Root 5 over 3 into 800. So if you simplify this one, it is approximately 596 kilometer per hour. So this is my dy over dx. So you can find it this value, the PDF file in the description box. Thank you.